Explanation has been a different thing, recommended as the hypothesis of the old. Boundless impact different appraisals. Besides made by an enormous number of analysts support this thought-giving attestation about how the universe started at any rate the current universe of science with new progressions brings us novel assessments and perspectives. These examinations challenge our places of view where certain pieces of data, such as those from Neil deGrasse Tyson, have turned into a gigant figure in this influencing universe of science now. Something drawing in is happening with the James Webb Space Telescope. It's fundamental to perceive something that could make us question the hypothesis of the universe's beginning. The James Webb Space Telescope has found 750 new universes. These systems are not exactly indistinguishable from what we expected, leading us to re-examine what we assumed we had some awareness of them. This discovery should assist us with appreciating how an enormous systems turned out to be, so it's not amazing that it's working up how we would have the option to unwind the universe before. Agents said that the Big Bang hypothesis was an exceptional explanation for how the universe started as per this hypothesis around 13.8 billion years ago. The universe showed up through a confounding occasion, like the insane story of the universe's introduction to the world. Anyway, the photos from the James Webb Space Telescope have tested this thought. These photos show universes that are more subtle, smoother, and more seasoned, to say the least, not quite the same as what the hypothesis of how things came to be predicts. As per the speculation, as the universe extends, objects ought to look more perceptible the farther away they are. Nevertheless, these bombastic designs try not to keep that standard. The hypothesis also states that at the universe's genuine beginning, every one of the matter that makes up the universe was squeezed into a second superdense point called a peckle. At this peculiarity was unbelievably hotter than anything that we could truly measure or make. This concept of a peculiarity comes from a lot of conditions in real science proposed by Albert Einstein called general relativity. Inside the peculiarity, all the stuff in the universe was crushed into a little space with extremely high density. It was a colossal amount of mass and energy packed into a tiny space. In simpler terms, specialists have continuously said that the hypothesis of how things came to be was how the universe started. Anyway, these new pictures from the James Webb Space Telescope are making us question that thought. The universe is it found don't fit with what the hypothesis expected, and the hypothesis explanation of the early universe probably won't be just about as strong as we once thought. In our persistent perspective on the universe, we perceive that all the energy in the universe started from a very hot and thick point called a peculiarity. This point is like the early stage for all that we view as in the universe. Today, after this peculiarity, the universe began to grow and create over roughly 13.7 billion years to become what it is today. The extension started with something numerous allude to as the Great Expansion, where the universe became incomprehensibly rapidly, significantly quicker than the speed of light. Maybe the genuine surface of space itself was growing, and everything in it was extending alongside it. This vast extension helped shape the universe by making things more uniform and CRE away for universe's stars and other influence. Plans to form as the universe continued to develop. It didn't extend as fast as during the extraordinary expansion. Anyway, it still kept on developing. We call this consistent development. Grandiose headway. Specialists have seen proof of this increment through things like the way light from far away universes changes in variety known as redshift. Now, how about we look at those dazzling pictures of new universes taken by the James Webb Space Telescope? To the larger part, these photographs look stunning, with different universes in a solitary frame anyway for inspectors. It's to some degree a shock that these photos don't match what their theories expected as an issue of some significance. These universes are basically more seasoned than expected, which challenges our perspective on system structure and progression as indicated by the hypothesis of the ancient Big Bang. There are, besides, significantly more self-absorbed frameworks than we expected. The hypothesis of the universe's start made surmises about the number of frameworks there should be and the way that they should be spread out. Anyway, the JWST pictures show a colossal number of universes, some more than expected. This makes specialists question whether the hypothesis estimates are accurate. A few specialists are in any event starting to overcompensate a bit, considering the way these revelations try not to coordinate their ideas in any capacity. One more amazing piece of the new bombastic designs is their flawlessness, which clashes with what the hypothesis of how things came to be proposed as indicated by the hypothesis. Universes should show abnormalities and plans in their designs due to how they framed and grew. However, photos from the JWST show universes that are very smooth without the standard complexity and brutality during the movement of the universe. All that makes up our universe was squeezed into a little space as the universe extended, and cool changes occurred in particles like protons, neutrons, and electrons, which started to associate with light and energy around them. These collaborations assumed an enormous part in the improvement of matter in the universe. In the initial 2 or 3 minutes after the Big Bang, there was a process called nucleosynthesis, which involved the formation of lightweight components like hydrogen and helium. These components set up for the development of stars, innumerable frameworks, and other complicated elements. As interminable history unfurled this mix of essential building blocks was a critical stage in the universe's improvement, advancing from a beginning condition of particles and energy to a state where matter began to structure, true to form the hypothesis of the ancient Big Bang had expected to see universes that were scattered and turbulent. Anyway, the JWST pictures tell a different story as opposed to blustery, scattered universes. The photographs uncover smooth, round, and winding shapes looking like the frameworks we find in the ongoing day universe. This alarming discovery challenges the thought that confusion is a normal piece of universe improvement in the event that there are few or no turbulent occasions happening in these universes as proposed by the hypothesis of how things came to be. It becomes irrational that minuscule universes would be able to develop to turn out to be more gigantic. Similarly, the optical intriguing quality anticipated by the growing universe speculation, where objects seem more modest with increasing distance because of extension, doesn't appear to be available in space. Specialists have noticed a striking example where tremendous designs will quite often group together in large social gatherings, forming various organizations across the universe. This enormous scope structure lines up with the presumptions made by the hypothesis of the universe's start. As per the hypothesis, the universe started in a very hot and thick state, and then extended and cooled over time. As the universe extended, gravity played a huge role in molding how matter was distributed and in organizing systems. The gravitational impacts anticipated by the hypothesis of the ancient Big Bang are steady with what we see today, with gravity arranging matter, prompting the grouping of cosmic systems and the development of interconnected filamentary structures known as the inestimable web. The presence of these system groupings and the grandiose web structure emphatically upholds the hypothesis of the ancient Big Bang. How systems are disseminated across the universe lines up with the gravitational impacts anticipated from an underlying, thick and extending state as proposed by the hypothesis, these elements counting, the bunching of frameworks, the grandiose Webb structure, and the spreading of universe bunches give strong proof that the universe developed from a very thick state and has been growing for billions of years. Presently, we should get back to the size of the design saw by the JWST. These photographs go against what we thought. We had some awareness of the Big Bang hypothesis as indicated by the hypothesis small universes ought to shape and stretch out through impacts and consolidations with other universes. Anyway, the universes made by the JWST feel very not quite the same as this thought, assuming that cosmic designs were impacting and converging as anticipated. We would see proof of these crashes, or on the other hand, consolidations, but the photos show something else. The Big Bang is still a very remarkable theory, essentially a thought without authoritative evidence. Now it is truly upheld by unquestionable proof, counting perspectives on the red shift of light and perceptions from far off universes. These offer support for the growing universe speculation studies, showing universes expanding their distance from each other, propose the expected steady increment anticipated by the hypothesis, the spread of light components like hydrogen and helium seen all through the universe is too steady. With the hypothesis of the universes start, furthermore, the large scope distribution of universes as revealed through galactic outlines matches the examples anticipated by the theory of how things came to be. One of the main pieces of proof for the Big Bang hypothesis is the discovery of the cosmic microwave background, CMB. The CMB is faint radiation that fills the whole universe and addresses the leftover sparkle of the Big Bang. This enormous radiation, previously recognized in 1965, still lines up with the forecasts made by the hypothesis of the universe is starting to notice attributes of the CMB. Its consistency and temperature distribution strongly support the likelihood that the universe was once in an exceptionally hot and thick state prior to going through expansion. A focal piece of the hypothesis of how things came to be, the discovery of the cosmic microwave background, is a basic piece of proof that offers us an uncommon look into the early minutes of the universe. It goes about as a leftover of the primary stages after the Big Bang, helping to check the extent of the universe's beginning and improvement